A curve is defined by the parametric equations x equals 2 cos theta and y equals 3 sine 2 theta. Show that dy dx equals a sine theta plus b cosec theta, where a and b are integers. Find the gradient of the normal to the curve at the point where theta equals pi over 6. Show that the Cartesian equation of the curve can be expressed as y squared equals px squared times 4 minus x squared, where p is a rational number. So here's the question then, let's have a look at it. We've got to get dy dx first, so a part 1. So dx d theta first then, let's get that. So dx d theta, which is here, cos goes to minus sine, minus 2 lots of sine theta. Dy d theta as well then. Sine 2 theta, goes to function of function. Sine goes to cos, so it's cosine 2 theta multiplied by the something differentiated, which is 2. 2 3s are 6. So we've got that. So dy dx then is equal to 6 cosine 2 theta divided by minus 2 sine theta. And the 2 goes into 6, there's a minus on top then. 2 into 6 3 times. The cos we can write as 1 minus 2 sine squared, can't we? I'm just looking at this and seeing there's a sign here. So I noticed that writing this version will produce that over the sine theta rather, because we divided the 2, didn't we? Sine theta. So that's that then. So that's equal to, well, minus times minus is a plus, 6 sine theta. And then we've got minus 3 over sine theta, which is minus 3 cosec theta. There we go. So we've got our values for the constants a and b. Okay, part 2, find the gradient of the normal at theta equals pi over 6, part 2. Theta equals pi over 6. The gradient of the tangent then, dy dx is equal to, here 6 sine pi over 6 is 6 times sine of 30 is a half. Minus 3 over sine 30 is a half again, isn't it? Which is 3. Take away 3 over half is 6, so it's equal to minus 3. So the gradient of the tangent is minus 3. So normal gradient, or the gradient of the normal really, is, well, what times what is minus 1? It's going to be 1 over 3, isn't it? So 1/3. Okay, so let's see what we've got here. Find the gradient of the normal. Yeah, that's fine. Part B. Show that y squared equals that is the Cartesian representation of the curve. So let's drag this down then and work with this. Save me writing it again. So I'll just take that and just move it. Managed to bring a bit of the t down with me. Okay, now we need the Cartesian equation then. So y, what's y equal to first of all? Is equal to, sine is 2 sine cos, so it's 6 sine theta cosine theta, isn't it? So if we do y squared, that will equal 36. All squared is sine squared and cos squared, which is equal to 36 times, sine squared can be written as 1 minus cos squared, times the cosine squared theta, which equals 36. 1 minus cos squared. Cos is x over 2, so it's 1 minus x over 2 squared, times x over 2 cos squared, because cos is x over 2, isn't it? So what have we got then? So what form do we want it in really, first of all? p, where p is rational, so we just need a 4 inside minus just the x squareds. So here we've got a 4, and we'll take a 4 outside the bracket, so it's 36. Now I'm going to take that 2 squared and take a 4 outside, and inside this will now be a 4 over 4 to get the 4 underneath, minus the x squared over 4. This will be another x squared, and this will be a 2 squared is 4. So that's equal to then 16, 36, it's 9 over 4, isn't it? Times 4 minus x squared times x squared. And how have they written it in the answer? We need the x squared at the front, don't we? So I'll squeeze the x squared in here. And it's 9 over 4x squared, 4 minus x squared. And p was rational. So p is 9 over 4.